In the world of computing, binary numbers are fundamental to how machines process and store information. While humans typically use the decimal system, which is base 10, computers rely on the binary system, which is base 2. This is because binary represents numbers using only 2 digits, 0 and 1, corresponding to the off and on states of a computer's electronic circuits. Despite the difference in bases, counting in binary is conceptually similar to counting in decimal. In decimal, when we count beyond 9, we add another digit, starting with 10. In binary, the same principle applies, but instead of adding a new digit after 9, we do so after 1. For example, starting from 0, binary counts as 0, 1, 10, 11, 100, 101, and so on. Each digit in a binary number represents a power of 2, just as each digit in a decimal number represents a power of 10. The rightmost digit is the least significant, representing 2 power 0, while the leftmost is the most significant, representing higher powers of 2. Converting binary numbers to decimal is a straightforward process, often done using a table. Each digit of the binary number is placed in a column, and these columns are labeled with powers of 2, starting from 2 + 0 on the right and increasing as you move left. For example, to convert the binary number 1101 into decimal, write it as 1 in the 2 × 3 column, 1 in the 2 × 2 column, 0 in the 2 × 1 column, and 1 in the 2 × 0 column. Then multiply each binary digit by its corresponding power of 2. 1 × 8 plus 1 × 4 plus 2 plus 1 and 1. Adding these values gives a decimal result of 13. To convert from decimal to binary, a common method involves subtracting powers of 2. Start with the largest power of 2 less than or equal to the decimal number. Subtract this value and place a 1 in the binary digit corresponding to that power. Repeat the process with the remainder, filling in zeros for powers of 2 not used. For instance, to convert the decimal number 19 to binary, the largest power of 2 less than 19 is 16, 2 × 4. Subtracting 16 from 19 leaves 3, so place a 1 in the 2 × 4 column. The next largest power of 2 is 2, 2 × 1, which fits into 3, so subtract 2, leaving 1. Place a 1 in the 2 × 1 column. Finally, 1, 2 × fits into the remaining value, so place a 1 in the 2 × 0 column. The resulting binary number is 101. Adding binary numbers uses column addition, similar to decimal addition, but with simpler rules because binary has only 2 digits. Start from the rightmost column and add the digits. If the sum is 0 or 1, write it directly in the result. If the sum is 2, write 0 in the result and carry over 1 to the next column. If the sum is 3, write 1 in the result and carry over 1. For example, when adding the binary numbers 1011 and 1101, start from the right. Adding 1 and 1 gives 0, with a carry of 1. Moving to the next column, add 1, the carry, 1, and 0, to get 0 with another carry of 1. Continue this process for all columns. The final result is 11,000. Through these methods, working with binary numbers becomes intuitive, demonstrating their similarity to decimal arithmetic while highlighting the simplicity of the binary system that underpins modern computing.